coding through and zoom in. So this particular paper is where I'm laying out all of the possible ways to ask questions about trig functions with all three trig functions. So the first thing I need you to understand is there's three of them. There's three trig functions. When I say function, formulas is another word you can use. I'm laying all of them out on here. We are going to cherry pick just the tangent questions first, because I have found in years past that if I teach tangent first, the kids tend to do well. If I throw all three of them at people, they tend to mess up, get confused, they don't have a clue. But if I show you just tangent first, and we practice with just tangent because it's repetitive, everyone does better. So we're going to cherry pick just the tangent questions first, and then practice it. And then depending on where we are in the class, we'll either go to the next two, or we might be at the end of the block and we'll be done. Okay. First, at the top of the paper is something you should already be able to do, because it is yesterday's lesson. For the triangles below, I want you to label the sides opposite, adjacent, or hypotenuse based on theta. So, looking at the first triangle, it's kind of hard to read, but that's a 3, 4, 5 triangle, and theta is in this bottom corner right here. What did I say to draw first in the triangle and to label first? The hypotenuse, because it never changes, right? Doesn't matter where theta is, the hypotenuse is always across from the right angle. So find the right angle, draw an arrow to the side farthest away. You can put an H if you want for hypotenuse, or you can put HYP. So the hypotenuse is 5. Then you reposition your mind from the angle that is marked theta. And you ask yourself, what would be the side considered opposite of theta? It's going to be the side farthest away, which would be 3. Put an O for opposite. If you will label hypotenuse first, opposite second, then by default the adjacent, which is the trickiest side for some people for whatever reason, will be the one left over. And to confirm that it is the adjacent, it should touch the angle marked theta. They should be touching. That's what adjacent means. So this is a 4. I want you to do the one to the right. You're labeling the one to the right, hypotenuse, opposite, adjacent. So draw your arrow from the right angle to the side farthest away. That's your hypotenuse. Go to theta, put an asterisk or a star to draw your attention from that corner now. The side opposite of theta is 2, and the side adjacent to theta is 1. On your paper, I would like you right here to draw an arrow to theta that's in the directions. I want you to write the word theta, and then I want you to put an equal sign and write fancy X. Don't let theta throw you off. It is just a Greek variable. Just like we use variables from our alphabet, theta is a letter of the Greek alphabet, and it is a variable in math. You might be wondering why on earth would they use a Greek letter in math? You know, what's the purpose? Why not just use another regular alphabetical letter? Because theta, because it's a Greek letter, lets you know that it's a missing angle. Whereas if I just used a regular English letter of the alphabet, you have no clue if it's representing an angle or a side length unless you have a picture where it's placed, right? If I say to you, I'm trying to find theta, and you know it's a trig problem, the mindset is, oh, well then it's a missing angle. Because Greek letters are only used for missing angle measures. Y'all with me? Please stay awake. Okay, so look at this next section. This is where I want you to do 4 practice problems on labeling. Because like I said yesterday, if you cannot master labeling the triangle, you're going to get trig wrong. So I need to make sure you know how to label it correctly. You don't have to write the full words. You could do the first 3 letters of the words, or you can do O-A-H, whatever you want to do. But please come to each of these triangles and label opposite, adjacent, and hypotenuse right now, and then we're going to check it. Then I want you to turn to a neighbor and compare answers. That's a study technique in not necessarily math, but look and see if you got the same thing. Right, just checking if these are finished. They switched. Okay, so looking through it, we should have labeled H first, then O, then A. Get it? Alright, here's the new stuff. So, trigonometry, or trig, is the study of, take your highlighter, it's the study of right triangles, not left triangles, but right ones, not wrong triangles, but right ones. I'm just seeing who's paying attention at this point. Trig is only used with right triangles. It does have to have a 90-degree angle in it, or you can't use trig. And that's actually not true, but that's what we say for geometry, so you don't mess it up. When you get into higher level, like pre-calculus, calculus, you actually can use trig with non-right triangles, but it does change the formula. For right, I just didn't want you to run through the streets and say, because Holcombe said you can't do that, because technically you can. So, we will only be dealing with right triangles. So when we get to word problems, not today, what picture can you draw to start your word problem? A right triangle. Okay? There are 3 formulas used in right triangle trig. Those three formulas or functions are sine, cosine, and tangent. Sine, cosine, and tangent. And then here's where I need you to highlight. Always make sure that your calculator is in degree mode. We are dealing with degrees. When a calculator is reset to its default factory settings, it goes to what's called radian mode. We're not going to address radians. Radians is another measurement for angles, angle measures. Kind of like I could measure a line using feet, inches, centimeters, meter, you know what I mean? So with angle measures, I could use degrees or radians. We are going to use degrees. So your calculator needs to be in degree mode or you're going to get the wrong answer. The good news is, if it's in the wrong mode, the answer is so wrong, it looks off. Like, it won't make sense. So that's how, so you can catch yourself if you forget to change it. How do you change it? Hit the mode button. You will see a menu pop up. You will notice where it says radian, degree. You just need to make sure degree is highlighted. Most of my calculators right now are in degree mode because of my college math class and what we're doing in there. But if it's not, you just arrow to it, to the word to degree, and then you hit enter to make it selected. Then to get out of it, just hit clear to get out of the menu. You can always check what mode you're in by simply looking at the top of the home screen. Look at the top of the home screen, and it will literally read degree or radian, depending on what mode you're in. Okay? All right. Come right here. Note theta, which is what looks like 0 with a line horizontally through the middle, is a Greek variable for missing angle measures. It's a Greek variable for missing angle measures. It means there's an angle missing. We don't know the name of or the value of it. It'd be like X for the missing length of the side. But if it's theta, it means it's an angle. Okay? I need you to know that there is more than just one letter of the Greek alphabet. Theta is the one we're going to use the most. And theta can be the one you use every time. If I throw a different one at you, you can change it to theta if you want. There are 3 more possible Greek letters that you may see. They mean the same thing. They mean a missing angle measure. They are, some of them you're familiar with, alpha, which looks like the little fish symbol, beta, which looks like a capital B that has a tail. Now the one you're probably not familiar with is gamma, which looks like a Y with a hook on the end. So if you see those are just more thetas, basically. If I gave you a triangle, don't draw this. If I gave you a triangle and it said theta here and alpha here, that means these are 2 different angle measures that we do not know. That's what that means. Now, if I give you a triangle with a theta here and a theta there, that would mean that that's 2 angles that I don't know that are the exact same measure. So it's just a variable, okay? Don't let it throw you off because it's foreign to you. All right. In the middle of your paper, you will see a giant box with the formulas for sine, cosine, and tangent. First of all, sine, cosine, tangent, abbreviated, is just simply the first 3 letters of the full word. No, it is not the word sin. It is not the word sin. It's a long I. Please don't call it sin because then that tells me you're not listening to what I'm saying. It is sine, cosine, tangent, or S-I-N, C-O-S, T-A-N. Okay? Now, Over here to the right, I want you to write in quotations, don't write big. You may want to see what all I write first to gauge how big you can write. Set up trig function. Okay, the reason I have this in quotations is because when we start these problems, the first thing I'm going to say to you is set up your trig function. Here's why you're writing this down. When I say set up your trig function, this means you're going to write one of the trig ratios, one of them, whichever one, sine, cosine, or tangent. You're going to have an angle. Let me actually change that to angle. Equals, then you're going to have a fraction bar. You're going to have one side here and one side here. So when I say set up your trig notation, or your trig function, you're going to write either sine, cosine, or tangent, angle measure, equals, fraction bar, and in the fraction goes just two of the three sides. Just two of them. Now how do you know what sides go there? Formulas. If you use sine, and I'm going to teach you how to know when to use which one, so don't worry about that. If you use sine, you will pull the two sides labeled opposite and hypotenuse. If you use cosine, Evan, please wake up, you will pull the two sides labeled adjacent and hypotenuse. If you pull tangent, or if you use tangent, you will pull the two sides labeled opposite and adjacent. Okay? Now, which one did I say we're learning first? I said we're going to start with tangent. So I need everybody to direct your attention to the tangent trig function. Tangent, angle measure, equals, it's fine, y'all. No child left behind is not actually a thing. It's actually, you don't get on the bus, you get left. Tangent, angle measure, equals, fraction bar, opposite over adjacent. Underneath the formulas, I want you to write this little acronym that I always show my students to help you memorize the formulas and be able to work through it faster. Notice that it's sine, and then it's the fraction O over H, right? Actually, you're going somewhere with that. Notice cosine is the fraction A over H. SOHCAHTOA. When I was in high school, we had to memorize it. We weren't given a formula sheet. And my math teacher showed us SOHCAHTOA. And that's how we memorized that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. So, I didn't mean to say so. Anyways, all right, let me pull up my, it does. Let me pull up my, why can I not get my calculator so you can see how to do this?
Coach Chris, what you doing? Oh yeah, let's get to sleep, by the way. Yeah, he's asleep. Yeah, go make him run.
His eyes are open. I can see it.
All right,
I can see it.
I've got my calculator pulled up. Now, we're going to focus on just tangent for right now, okay? So look right here. Look at the directions. You need to learn how to read the directions and know what it's asking you to do without me saying, oh, it's asking you to do this. So you got to get there, okay, on your own. Read the directions. It says, calculate the following trig values. Round your answer to the nearest 10 thousandths. Okay. Yeah, it is a big number. When you're dealing with trig, it's very common to have to round to a farther decimal. And that's because if you round to like the nearest tenth, you're cutting off so much value that it's inaccurate. It's not accurate. have a real quick crash course refresher. Let's have a real quick crash course refresher on rounding. Because I don't want you to get these wrong because you rounded wrong. You had all the work right, but you rounded wrong. So let's refresh you on rounding. If I had, well, actually, I'm just going to do zeros. All right. So I've got some type of number in front of me, right? A decimal. The first number after the decimal is what place? Tenths place. The reason this is called the tenths, or the tenth, is because how many zeros are in the number 10? 1. Okay, the second number after the decimal, no, is called the hundredths. And the reason it's called the hundredth is because how many zeros are in 100? 2. 2, how many zeros, not digits. It's all right. Don't listen to me, please. There's 2 zeros in 100. So if I say round to the nearest hundredth, you're rounding to 2 decimal places. If I say round to the nearest, what's this one? What, 10, 100, 1,000.
10,000.
The next one's 10,000.
How many zeros are in 1,000? 3. So the third digit after the decimal is the thousands place. This right here, I'm running out of room, would be the 10,000ths. How many zeros are in 10,000? 4. So it means 4 numbers after the decimal. So if I ever tell you to round to something, all you have to do is ask yourself how many zeros are in that number, and that's what you're rounding to. Now, let's have a refresher on rounding. For example, well, no, not for example. Let's refresh you.
0.19.
Let me put a 0 here.
3, 8, 2, 8.
Okay. If it is between what, like, what's the threshold to round down?
4.
4. So between 0 to 4 in this position, right, means round down. Okay, and if it's 5 or higher, I'm just going to put a plus 5 to 9, right? It means round up. Okay, so for example, if I gave you this number and I said round to the nearest 10th, there's 1 0 in 10, so that means this is the number I'm rounding or not, which means you're checking the next number beside it, right? So this is the number you check. Okay, this would round to what? To the tenths, 1.2. Okay, what if it was 1.235? And I said round to the nearest 10. Still 1.2. My question is, some people see a 5 just somewhere in the picture, and they think, oh, that's gonna round the 3 up. They domino round. There's no domino rounding. When you're rounding a number, it only rounds one time. Okay? Now, there are special cases where, like, let's say we had 1.96, and I said round that to the nearest 10. Okay, well that means one number after the decimal, which means check the second digit to see if it rounds. Will this round up or down? I shouldn't say down. Will it round up or stay the same? It's going to round up, right? Y'all staying focused? This 6 is going to bump this 9 up to what? To a 10. Now the logic is, can you put a 10 in one position? No. So the 1 carries over here, and this becomes a 0. It does not domino round. There's no domino rounding. A lot of people get that confused, and they think they're domino rounding there. You're not. You're saying 10 won't fit in this one position, so the 1 carries over. Okay? So be careful with your rounding. Alright. Already losing half of y'all. Okay, look right here. Calculate the following trig values. Round your answer to the nearest 10,000. If you need to, write it 10,000 so you can remind yourself that is 4 decimal places, which means check the 5th number after the decimal. That's what you're checking. Okay, how do you do it? We're just doing tangent, y'all. We're just doing tangent.
You just do.
Don't highlight it. So you go to your calculator and you just type exactly what you see. I see tan 87. Tan 87. You don't even have to close the parentheses. Enter. If you're going to get a very ugly decimal, you're going to check which digit after. You check the 5th to see if the 4th needs to change. The 5th digit after is a 3, which is not high enough, so I leave it alone, right? So it'd be 19.0811. That's it. That's all she wrote. So if I say evaluate the trig function and I have it just says tan of an angle, you just type it in and round. Now that's so simple. There's not a lot of those because there's not a lot of places to mess up on that. I mean, there's no way to change that question and make it even more challenging. Now come right here. This is where we're going to practice setting it up. And this is what I mean by set up the trig function. So we have a picture here of a triangle. And the directions say, use the triangle below to write the trig ratio for each trig function and simplify if possible. Let's refresh your memory on what ratio means. Ratio is a fancy word for fraction. So if I say to you, I need you to find the trig ratio, that means I want you to find the fraction that comes from the formula based on the sides. Now, we are only doing what first? No. We're only doing tan today. This is going to get crowded tomorrow, so don't write big here. We're going to put all 3 trig functions in this space, so don't write big. So from the angle that's 72 degrees, from 72, set up the trig function. Okay, so tan, what's the angle? 72 equals fraction bar. The fraction bar gets filled in with the formula for tangent, which are always the sides, opposite and adjacent in this case for tangent. Now, opposite of what? Opposite of the 72, because that's the angle you're using. So go to this picture, focus your attention from 72. What's opposite of 72? 55. What's adjacent to 72? Now your question, great question. A lot of people get the hypotenuse confused as a possible adjacent side. But remember I said in the very beginning, if you label your hypotenuse, you will never mistake it as adjacent. Yes. 27 is the adjacent side. So if I say set up your trig function for tangent of 72 degrees, this would be what you write. Now I want you to repeat this exact same thing, but over here from what angle? 18. So set it up. Tan what? No. 18 equals fraction bar. Fill in your fraction with what's opposite of 18 and what's adjacent to 18.
but are you in
Nope.
general?
We will. Right now, we don't have any variables.
Oh, okay.
This is just practicing setting it up
I'm over
with
here
with
trying.
all of the numbers given. What is the trig ratio for tan 18? 27/55, right? Everybody agree? How did you get that? Because the formula for tan is opposite over adjacent, and from the 18, opposite is 27 and adjacent is 55. Please take your highlighter and highlight right here. You never calculate the trig value of the 90-degree angle. Never, ever calculate the trig value of a 90-degree angle. The 90-degree angle is there to help you label the hypotenuse, and that's it. All right, let's go to the back. We are jumping around to just tangent questions. Just tangent. So we're gonna, you don't have to take your highlighter because tomorrow we're gonna fill in the ones that are left. I'm going to highlight the ones we're going to address right now. We've got 7, 13, 14, 19, 21. And then when we get here, we'll look at it. All right. Thank y'all for not talking on teaching. It's great. So look at number 7. Look at the directions. It says draw and label right triangle ABC with the following trig ratio given to you. So the purpose of this question is to teach you that if I tell you the tangent of angle A is, say, 4/5, I have just told you 2 side measures from the triangle. How do you know what side measures I've given you? Because of the formula for tangent. All right, so what's the formula for tangent again? So let's write it right here to refresh our memory. So I'm going to draw a right triangle. Now, angle A is what's in the trig function. Does it need to go at the 90-degree angle? No. We just said the 90-degree angle is never used. So angle A has to be one of the acute angles. Depending on where you, listen to me carefully, depending on where you put angle A, and you get to choose, you have 2 choices, will change where you put your numbers. So if you choose to put angle A at the top, your opposite and adjacent will be different than your neighbor if they put angle A at the bottom. Are you wrong? No. Is your neighbor wrong? No. This is a free choice type of question. So it has 2 possible answers. I chose to put angle A at the bottom. Because my angle A is at the bottom, tangent is opposite over adjacent. This means from angle A, what is the length of the side opposite of it? 17. So I'm going to go to my picture. I'm going to go to the side farthest away, not touching, that's opposite. And I'm going to label it 17. Then what's the side adjacent? 15. So I'm going to go to the side touching angle A, but it's not the hypotenuse. And I'm going to label 15. If you need to label the hypotenuse, or at least draw an arrow to it, you can. Now, if your neighbor put angle A at the top, then their 17 and 15 would be switched, and they would still be correct. All right, look at the next section of questions. Referring to the diagram, give the value of the trig ratio. This means they want the fraction. Okay, so come to the picture. Let's draw an arrow to our hypotenuse. Look at number 13. It says, what is the trig ratio for angle P? Tan of angle P would be what? What fraction? 3/4. Does everybody agree? Opposite of P is 3. Adjacent to P is 4, so that's correct. What would the trig ratio be for tan of angle Q? 4/3. Tangent, sorry, this is one of my favorite units because one, it's really important. Two, because I've taught it for so many years, I figured out how to introduce it and how to practice it so that it sets you up to feel like it's easy. Because it actually is easy, as long as you're paying attention and you're trying. Look at 19. Give the value of the trig ratio. Now we're using a different picture here. I need, this one's a trick.
You just have to solve it.
Ow.
Go back to what we did 2 days ago. We have a right triangle with how many sides given? 2. We need the third side, right? How do we find it? Pythagorean theorem.
I hate trig already.
So draw an arrow to the hypotenuse so you know what needs to go in as C. This is your C. Here's the formula for Pythagorean theorem if you forgot it. And then what I want you to do is find that missing side right now. And it is pretty. It's pretty. So find it. See if you remember. This is a good practice before our quiz. Which is not today, don't worry. Or tomorrow. No, probably this Friday. Yeah, you should get 25, and then when you square root 25, you get what? Get 5.
So then 21.
So this is 5. Now fill in the trig ratio for 19 and 21. Did you get 5?
I got 5, but I didn't talk.
That is a 3, 4, 5 triangle. That's just coincidence. And tomorrow is when we were going to find that because the hypotenuse is used in sine and cosine. All right, what's the trig ratio for tangent of angle P? 5/12. What about tangent of angle Q? Very good. All right. The first part of your practice assignment is going to be just writing the trig ratio. Okay? I have an IXL, so remember how the IXL works. We only get 10 questions free. And it is just tangent. We're going to try it in a minute. We're not done. Don't pack up. We're going to try it in a minute. I'm just letting you know that's going to be the first part of today's practice. Okay? Now let's get to where it's actually, there's some math, like some actual calculations, set it up, solve involved. And that's down here. Okay? So, what's the purpose of trig? There's a lot of purpose, but one of the first purposes, look at number 22. If I said to you, tell me the length of the side marked X, can you use the Pythagorean theorem here?
No.
Why can you not use the Pythagorean theorem in 22? Because you need 2 sides given so that you only have one missing variable in the Pythagorean theorem, right? Y'all staying with me?
Yeah.
Number 22 only gives me one side, so I cannot use the Pythagorean theorem here. Notice it says if you have only one missing side of a right triangle, you can use the Pythagorean theorem. We're going to abbreviate theorem to find the missing length. But if you have more than one missing side, you have to use trig. All right, now let me show you how to do it. This goes back to the front of the paper where I made you write down the quote. Set up your trig function. Label your triangle, then set up your trig function. So let's look at number 22. When I say label your triangle, I'm referring to what we did yesterday and what we did at the beginning of the notes. Draw an arrow from the right angle to the hypotenuse. Then you're going to go to the acute angle that they give you. So I'm going to go here. You're going to put an asterisk. Now you're going to label the opposite and the adjacent. What's x? Opposite. What's 10? When you draw an arrow from the right angle to the hypotenuse, look at this. If it's blank, there's nothing there, no variable, no number, you're using tangent every time. Okay? So we're using tangent. So the question is, how do we know which trig function to use? Because you have 3 of them. Well, you know today we're only using tangent. That's how you know today, right? And how would you know, though, if I just threw them all at you? If you drew an arrow from the right angle to the hypotenuse and it's blank, it's tangent. Okay? Go with me? All right. So you label your picture. You determine which trig function you're using. We're using tangent. And now you set it up. This goes to that what we wrote on the front of your paper. So set it up. Tangent. Angle measure. What's the angle? 27. Equals fraction bar. You fill the fraction in based on the formula for the trig function you're using. What's the formula for tangent? Opposite over adjacent. If you've labeled your picture, it's a matter of just plugging it in. Opposite is x, adjacent is 10. Now, Ben, you said, do we ever actually solve anything or whatever? Yes, right here. We have a variable in this equation. We need to get the variable by itself. The variable is in the fraction, right? The first step to getting this by itself is cross multiplying. Now, you're not doing the full-on cross multiplying like what we did last week, because there's no fraction over here on the left, right?
Yeah.
What number is actually understood to be under here?
1.
The 1. So when I cross multiply that 1, nothing changes. So really the only action comes from the bottom of the fraction is cross multiplying over to the front of the left side. I want you to start drawing, I call it the elbow arrow. Okay? I want you to draw, instead of imagining, let me show you this. Red means wrong here. I don't want you to draw the arrow right there, because then you're going to instinctively multiply 27 times 10, and now you've completely botched the whole problem. You never change the angle. The angle doesn't change. So instead, if you will draw the elbow arrow, it will remind you, hey, that goes to the front. That does not go with the 27. It goes to the front. So we end up with 10 tan 27 degrees equals x. And now the beauty of it is, in this case, x is now by itself, which means now I'm ready to go to the calculator and type it in. Y'all stay awake. So I'm going to go to the calculator, and I'm going to type exactly what I see. I see 10. Got gotta change that like to 13 or something. I see 10, push the 10 button, then I see 27. You don't even have to close the parentheses because that's the end of what we need to type. And then hit enter. Now, I don't remember,
Pretty numbers.
what did they say to go? No, there's not.
10.
10? No, not this time. I think this time it's the tenths. Because we're talking about the length of the side. So, if I'm rounding to the nearest tenth, that means I'm checking the second digit to see if it pushes the first digit up or not. Does it round up? Yes, it becomes what? 5.1. Now go to 23. My first question to you is 23 a tangent problem? How do you know?
Because the hypotenuse is
There you go. Draw an arrow from the right angle to the hypotenuse. If it's blank, it is a tangent problem. So we're going to set it up. Tan, angle measure. What do I write for the angle? 46 equals fraction bar. Now you might be thinking, how do I fill in my fraction? Well, go back to the picture and label the opposite and the adjacent. 7 is opposite, x is adjacent. So it'd be 7 over x.
Well, how do you do this? Because if you use elbow arrow, you have x.
Very good. That's the first step. So we're going to elbow arrow that bottom of the fraction, which in this case is a variable, over to the front. We got x tan 46 equals 7. Now, in the last problem, when we did this, we were ready to go to the calculator. In this problem, we have one more step to go, and that is to move. Now, the tan 46 is connected. I need you to, y'all know those little wooden blocks kids play with? I need you, not Jenga, building blocks. I need you to imagine like a wooden block with tan 46 written on it, which means when I go to move it, the whole thing goes with it, right?
Yeah.
So this tan 46 right here is in the way. X is not by itself because of tan 46. How's it attached? Multiplication. How do you undo multiplication? Division. Watch how I write this. So I'm going to mark this out to show that it's coming over here underneath. Thank you for not talking. And then now I can go to my calculator. And I'm going to type what in my calculator? 7 divide tan 46. We're going to the nearest tenth, so it's going to be 6.8. Right? Okay, so now let me, if you'll put your pencil down, look up here. You don't have to highlight this if you don't want to. So I want you to understand that when we practice this, which is what we're about to do, there are only 2 scenarios. There's only 2 scenarios of how your problem is going to set up. And the scenarios are x is either in the top of the fraction or x is in the bottom of the fraction. Notice that if the variable is in the top of the fraction, it's a shorter problem, right? You get to your calculator faster. If the variable's in the bottom of the fraction, you still start it the same way, elbow arrow. But then you have to do one more step before you can go to your calculator. These are the only 2 scenarios for every practice problem. You with me? You will not have some secret third scenario that's 15 steps. That's not going to happen. You've done something wrong if it's not 1 step or 2 steps. You with me? I want you to do the iExcel first before we go to the Delta Math. The iExcel is where you are simply typing the fraction for tangent. That's all you're typing. Then we're going to go to the Delta Math where you're actually solving. So, go to iExcel. Actually, you don't have to go to iExcel. Go to what's it called? Google Classroom, and I'll post it. And we're just going to do our 10 free.